So, we've all heard that Australia has the worst mammal extinction rate in the world, and that is a statistic that we should not be proud of. There's a wide range of threats that have caused this decline seen in our mammals. These include predation and competition from introduced species, habitat fragmentation, and disease, just to name a few. For this study, we focused our attention to both logging and fire, as these are impacts which are known to affect mammals very differently. One species where its response to these variables is largely unknown is the yellow-footed Antechinus. This small carnivorous marsupial depends heavily on a grassy and shrubby understory as well as hollow-forming trees, so we expect both logging and fire to have some impact on the species. Therefore, the aim of this study was to assess the mean relative abundance of yellow-footed Antechinus in response to fire and logging. The study site comprised of 6 properties in Helidon Hills of southeast Queensland. 3 privately owned properties included Helidon, Burkett and Valmar, while government-owned properties included Ergon North, Ergon West and Ergon East. Each property had varied histories of fire and logging. This image represents an example layout of the method used for sampling Antechinus. At each property, 8 trap lines containing 10 Elliott traps each were set by a student walking in an approximately straight line. 1 trap was placed after every 15 metres walked, and traps were set for 3 nights at all 6 properties. This table shows that the fitted means of Antechinus abundance was slightly higher at logged properties compared to unlogged properties, while the fitted means were considerably lower at slightly burnt properties compared to severely burnt properties. This indicates that the yellow-footed Antechinus may have a positive association with severely burnt areas. To test this, a two-way ANOVA created in Minitab was generated to determine if there was any statistically significant differences between Antechinus abundance and fire or logging. We can see from this ANOVA table that the p-values are above 0.05 for both factors, and therefore neither fire or logging was significant to the mean relative abundance of Antechinus for this study. One explanation for insignificant results is likely due to the insufficient sample size. Also, because there were no control sites and logging and burning were performed on the same properties, the two variables were essentially indifferentiable from each other. It's also possible that there were other factors which may have influenced the results and which weren't accounted for in this study. These may include predation, proximity to roads and tracks, or the presence and frequency of recreational activities in the area. Therefore, it's highly recommended that future research aims to substantially increase the data size and account for underlying and potentially influential variables to achieve more convincing evidence. Thank you.